today's question is problem number 2872. Maximum number of K-divisible components. That is the problem of the day on Leetcode. So let's read the problem. There is an undirected tree with n nodes labeled from 0 to n minus 1. You are given an integer n and a 2D array edges of length n minus 1, where edges at I is equal to ai and bi, indicating that there is an edge between nodes ai and bi. This edge will be basically a two-way edge, that is from A to B and from B to A. Okay, keep this in mind. As this is an undirected graph, undirected tree, sorry, there will be no cycles. Okay, so it will be like this. You are also given a zero indexed array values of length n, where values at I is the value associated with the ith node and an integer k. So basically, this array of values would be given to us with the number of values equal to the number of nodes. So there you can see 5 nodes, so 5 values. So this is the value associated with node number 0, with node number 1, with node number 2. Okay. A valid split of a tree is obtained by removing any set of edges, possibly empty, from the tree such that the resulting component all have values that are divisible by k, where the value of a connected component is the sum of the values of its nodes. Return the maximum number of components. So basically, this will be the tree given to us, and we have to divide it in such maximum number of components that all the after the splitting, all the components all the components sum is all the components each for this, like this, for this component, the sum of the values for these two nodes, that is 1 and 3, which would be 8 and 4, so it would be 12. It should be divisible by k is given as 6, so 12 is divisible by 6, so this can be a component, and likewise this 2, 4 and 0. So 0 is 1, 1 plus 1, that is 2, and plus 4, that is 6. So 6 is divisible by 6. So this is the other component, and they cannot be further broken down into any other components. Okay. Yeah. So this is the question. Like if we see, if we break this edge, if we break 2, 4, then what would be the components? One is this, and as we saw, the sum of the values of this component would be divisible by k. This would become one component, and this 4 would become one component. So let's see, check the sum of these values, 2, 0 and 2. That would be 1 and 1. 2. 2 is not divisible by 6. So this cannot be a valid split. Okay. This is the general problem. So let's see the constraints. The n is given as between 1 and 3 into 10 to the power 4 into power 4. Okay. 3 into 10 to the power 4. And that's it. The edges length is n minus 1. And one value of edges would be 2, that is A and B, the two nodes between which the edge exists. And that's it. So now let's look at the solution for this. So let me just draw this tree. Okay, wait a second. So let's look at the solution for this. We would be using DFS traversal. What we will do is, initially we would create a visited array for each node. It would be false, and one we have to simply, we are given the edges, all the edges, so we have to first make a adjacency list. Okay, you can also use a matrix, but it would be more space consuming. Okay, so in this part, as you can see, we just simply traverse the edges vector, and for we extract both the u and v, and simply a and b, and we insert uh, b in a and a and b, vice versa, as it is an undirected tree. So this would be it, and after this, for the final answer, initially the components are 0. So what you will do is simply call DFS from the starting. You can call from any node. I called from 0th node, and we would pass the adjacency matrix list and the values vector, the components, the value of k, and the visited. And what is the basic idea is that we start from this 0th node, and we apply DFS to all its node. So here for 0, what will happen is we would calculate the sum at this node. So for this sum would be 0, that is 1. For this the sum would be 0. Okay, let me just once again. P for 0, let me just bring it here. For 0, for 0th node the sum would be what? 0th node sum would be 1, and then we would move on to the to its neighbor, that is 2. Keep in mind we are using DFS, not BFS. So 2 would come, and for 2 what would be the sum? For 2 the sum would be 1. Okay, from here I am seeing this values vector. Okay, and for as we were initially on 0 and we made a call to 2, and then we would see 2. Let me just make a visited vector. 0 is false, 1 is false, 2 is false, 3 is false, 4 is false. Initially all these were false. We visited 0, so it would become true. We visited 1, so it would become true. And now from 2 we have two options. One, not one, sorry. This is false. We visited 2. From 2 we have two options, either go to 4 or either go to 1. Let's go to 4. And we would mark this as true. And for 4, what would be the sum? So 4, the sum would be 4. Okay, 4. As now from 4 we can see that 4, from 4 we cannot go anywhere else. We can only go to 2, but 2 is already visited, as you can see here. So what we will do, we will check if the sum for this 4 is divisible by k or not. So we will see if 4 mod, what is the value of k here? 6 k, which comes out to be 4. So what we will do, see here, for 4 what will happen, all its neighbor will be traversed, and there will be no neighbors found, as we are checking here if the neighbor should not be visited. You see here, and its neighbor is only 2 and it is visited. So what we will do, we will calculate the sum for this, and the sum for this would come out to be 4, and then we will sum is equal to sum mod k. 4 mod 6, what would it become? It would become 4. Okay, and then if we check if the sum equal to 0, then the components will be plus plus. Let me write down the components. So it is initially 0. So this condition is false, so we return sum from this. From this 4 to 2, sum is returned as 4. So when we are back on 2, we use DFS. So then we go to 1. For 1, we calculate the sum. It comes out to be 8. And from 1, we go to 3. So for 3, what it comes out to be the sum comes out to be 4. And you can see as from 3, we cannot go anywhere else. So the sum would be calculated, and sum would be mod by k, mod 6. So what it would become? It would become 4 only. Then 4 would be returned from this to this. And you can see here, as we are doing sum is equal to sum plus this. So when we are standing at, when we came back to mode 1 from 3, then at 1 the sum was initially 8, and plus the sum returned from 3 was 4. So 4 is added to it. So it now becomes 12. And then this condition is checked. Sum is equal to sum mod k. So it becomes, if mod 6, so it becomes 0. Okay, so if you check if the sum is 0, then components plus plus. So basically we got one component, that is 1 and 3. This part we got as a component, so what the number of components, it becomes 1. Okay, so now we return sum to 2 to its parent. Okay, so that sum becomes 2. Now when we are standing at 2, what we had done that from 4 it came out, from 4 it the sum came was 4. It would become 4. And from 1, what sum there came? 0. So it would plus 0. So it would become 5. then sum is equal to sum mod k, so it would be mod 6, mod 6, which would be which would remain as 5. And then what would happen? From we came to 2 from 0, so 2 would return 5 to 0, so 0 will be plus 5, 1 plus 5, sorry. So what would this become? This would become 6. Now we'll do the same thing. Sum is equal to sum mod k, it would mod 6, so it would become 0. It would become 0. So now what would happen if sum is equal to 0, components plus plus, to sum is 0, components would become 2, and that's the answer what is required. Okay, so basically what we are doing, we are applying greedy over here, that we start from, we apply DFS till we cannot go any further, and while coming back we compute the total sum of the current component. And when we go to 0, 0 to 2, 2 to 4, and we see from 4 we cannot go anywhere else. We compute the sum for 4, and we check if this, the sum of this component is, which is only 4, is divisible by k or not. If it is divisible, then we increase the number of component and return 0 to this, indicating that this component has become an individual component. So this would not be added in this. Otherwise, the sum is returned over here, and it is added to the sum of this, and likewise further, and the whole tree is traversed. Okay, so I hope you got the idea for this, and uh, the code will be provided. This code will be provided in the comment section. First comment, I will be pinning it, and please do like the video. I hope you understood it. Thank you. Bye.